Let's picture the year of 2040. I'm entering an airliner in Frankfurt or Barcelona airport and I want to cross the Atlantic. I want to go to the United States. How do you think is this airplane run? Do you think e-fuels will play a role? Is that hydrogen that is burnt directly in a new engine? Or are we talking about fuel cells that kind of run an electric motor to cross the Atlantic? Is that realistic? Welcome to Battery Generation, your electromobility podcast for European battery research. Dear audience, it's the day of the day. We are going to talk about hydrogen in Europe today. But before we start, make sure to hit that subscribe button if you like what you hear. I have a great guest in the show tonight. It is Dr. Lluís Soler Turu. Hello.
Hi.
Lluís, you are a material researcher at the Department of Chemical Engineering and the Specific Center for Hydrogen Research at the Politècnic University of Catalunya in Barcelona. Lluís, hydrogen-based energy storage is still among the most controversially discussed topics within the energy transition. I get the feeling that there is a group of haters that tell us all the time it's never going to work. And then we got the scientific group that's actually working on materials that are going to enable hydrogen technologies. How do you see this debate?
Indeed, there are many reasons. There are many challenges to overcome. So we have some efficiency concerns when we talk about electrolyzers, fuel cells, the cost, infrastructure, safety issues about hydrogen. For sure, competing technologies, because there are other technologies that they would like to get their space in the non-zero emissions scenario. But I think all of them will survive because all of them have pros and cons, so advantages and disadvantages. And when one technology is not reaching the main advantages for one particular application, the other technology could do it. So in this case, I'm pretty sure hydrogen will have its own space.
Lluís, why don't you tell us about your work in Barcelona and how far are you in your research when it comes to fuel cells, when it comes to electrolyzers and the transportational systems of hydrogen?
We cover production, we cover storage, we cover purification, we cover fuel cells applications, but also chemical applications of using hydrogen as a raw material. We cover balance of plant, process control, so a little bit of everything. And we have these synergies between different groups from different departments to get this whole solution.
I know that fuel cells transform hydrogen and oxygen into electricity and heat, and electrolyzers basically do the opposite, right?
In easy words, it's something like this. So in an electrolyzer is, if you imagine like a black box, you introduce water, you plug electricity in there, and you get hydrogen and oxygen and also a little bit of heat that you have to remove. And same for hydrogen fuel cells. Is the same chemical reaction, but in opposite direction. We recombine hydrogen and oxygen to produce electricity, water vapor, and heat.
Let's picture a working future hydrogen economy in Europe. How many of these fuel cells and electrolyzers do we need at the end?
If you look in global terms, all over the world, there is a huge hydrogen market, but this hydrogen market is for using hydrogen as a raw material. You can use hydrogen for ammonia production as a fertilizer, methanol production, refining of chemicals in the petrochemical industry, hydrogenation of oils and fats, and also steel production in the metallurgical industry. So these 5 uses, they are consuming, if I'm not wrong, 110 million tons of hydrogen per year, which is a lot, right? So there are no energetic applications in here. And this is gray hydrogen. It's associated to carbon dioxide emissions. So that would be probably the main approach, trying to switch this gray hydrogen for renewable hydrogen, or what we say green hydrogen, in order to decrease the associated carbon dioxide emissions to this existing hydrogen market, right? But then there is all these emerging hydrogen market for energetic applications. Then there are a lot of plants in different countries in Europe and all over the world. And something is the plan from the governments. And then there are the final investment decisions from companies that they are a little bit unbalanced, I would say.
We all know this hydrogen ladder by Michael Liebreich. We actually talked to him directly in the German-speaking podcast. For everyone who doesn't know the work of Michael Liebreich, this hydrogen ladder is a structured ranking of hydrogen applications based on their viability and efficiency. It kind of categorizes different use cases from the most promising applications, such as jet aviation, shipping, and the production of fertilizers, as you just mentioned. And at the bottom, it lists least viable applications considering the factors costs, efficiency, and safety. Lluís, what is your opinion on this hydrogen ladder?
I'm actually quite agree with hydrogen ladder from Michael Liebreich. I would say there are some uses that there is no alternative. You have to use hydrogen as a raw chemical to produce that particular reaction. So there is no other option. But for energetic purposes, I don't remember exactly in which position he plays heavy trucks or buses or ships or airplanes. So it's a trade-off depending on the heavy-duty vehicle, because sometimes what you win in terms of recharging time, then you lose it in terms of price. So hydrogen bus, let's say, it's more expensive than an electric bus. So at some point, I would say I'm quite agree with this ladder, but for sure, I think heavy duty vehicles probably should be a little bit on the top.
In Germany, actually, we see a lack of any sort of hydrogen gas. We simply don't produce enough for our mobility solution. So where do you guys get your hydrogen from?
Ideally, the hydrogen should be produced using renewable energy. Here we have a lot of sun and we have wind as well. So we have renewable energies. They are intermittent, but on the peaks where we are producing more electricity than the one that we are consuming, in that part, we can store this surplus of energy in the form of hydrogen.
If you're not from Europe or not listening from the continent of Europe, actually, we are building up our own hydrogen network over here. Lluís is sitting in Spain. I am from Germany. And there's actually a core network, pipeline network that is going to be built up so we can kind of exchange supply and demand. But Lluís, let's first of all talk about a great example of the first hydrogen economy. Let's talk about jet aviation here. Traditionally, we were talking about burning hydrogen straight within new engines or in fuel cells. So there is like two different solutions how we can use hydrogen in aviation. What do you think about these two solutions? What would you prefer?
I'm not sure if the solution will be electrical airplanes or just doing this retrofit of the engines instead of burning conventional fossil fuels or sustainable aviation fuels, change it into hydrogen. I don't know what's going to happen. The trend, I would say, it's combining carbon dioxide with hydrogen to produce these sustainable aviation fuels, right? But we have both companies, Boeing and Airbus, both are doing research on switching from fossil fuels to hydrogen technologies. But honestly, I'm not 100% sure if there will be fuel cell based, so that means electrical engine, or still burning fuel, but in case would be hydrogen fuel, so no carbon dioxide emissions.
And then we got a third solution, which is called e-fuels. You also need green hydrogen for producing e-fuels. I'm actually considering this since Airbus, you just mentioned it, delayed their hydrogen aircraft programs, pushing hydrogen back by 5 to 10 years, maybe up until 2035 or so. They are now focusing more and more on e-fuels. where hydrogen is needed as well. What's your take on that?
E-fuels, I think it's a common sense technology. The E is coming from electricity, right? So we produce this renewable electricity to produce a chemical energy carrier, which is hydrogen. And then we recombine this hydrogen with carbon dioxide to produce hydrocarbons, long chain hydrocarbons like kerosene or other fuels that are used for aviation. We can capture carbon dioxide in stationary facilities or places where they have carbon dioxide emissions, recombine it with hydrogen, produce these fuels, and then send it to the airplanes. And then the whole cycle, it's neutral in carbon dioxide emissions because we are capturing carbon dioxide from one place and then emitting carbon dioxide in the airplane, and this carbon dioxide at some point should be reabsorbed by vegetables, by plants. So at some point we are kind of closing the cycle if we are not using any more fossil fuels. This would be the point, using biomass as a source material to generate this first carbon dioxide that we have to convert into e-fuels.
Well, then let's picture the year of 2040. I'm entering an airliner in Frankfurt or Barcelona airport, and I want to cross the Atlantic. I want to go to the United States. How do you think is this airplane run? Do you think e-fuels will play a role? Is that hydrogen that is burnt directly in a new engine? Or are we talking about fuel cells that kind of run an electric motor to cross the Atlantic? Is that these three solutions? Is that realistic?
I think e-fuels can be common use in most of the airports, at least in Europe, in 15 years, which is 2040, right? But I don't think that pure hydrogen commercial aviation applications will be ready for just in 15 years for 2040. I think it's too much.
All right, Lluís, let's talk about the materials that are used for fuel cells and electrolyzers. Like in batteries, of course, every application needs very, very individual fuel cells or electrolyzers. What kind of materials do we find inside these two devices?
An electrolyzer and a fuel cell, they contain materials that are called electrodes, where the chemical, or in this case, electrochemical reaction happens. Some of the electrolyzers and most of the fuel cells contain also membranes, right? We have also bipolar plates and gas diffusion layers. So we have different materials. If we focus on, for example, what we call proton exchange membrane technology. So we have proton exchange membrane electrolyzers or proton exchange membrane fuel cells. This membrane that exchange protons usually is a fluorinated polymer, right? So this is expensive and it's harmful from the environment. The electrocatalysts for the electrodes, depending on the technology, they could contain iridium or platinum. So these are platinum group metals. We have a scarcity of those materials on the Earth's crust. Depending on the electrolytes, or if we are using high temperature technologies, we have to use yttrium, zirconium, strontium, lanthanum, these kind of metals. At some point, both technologies, electrolyzers and fuel cells, they contain rare earth metals or platinum group metals and some polymers that could be harmful for the environment.
And can these fuel cells, when they're done, when they're somehow not doing their job anymore, can they be recycled easily?
The platinum group metals, I would say they can be easily recyclable. Like these are like the catalysts from the automotive cars. So at the end of the exhaust pipeline where you get that smoke, there are catalysts and they are just getting recycled: rhodium, platinum, even rare earth metals. There are chemical routes to get those metals back and recycle, same as batteries, right? But there are some other components, like for instance, these fluorinated polymers that could be a little bit harder to recycle. So in terms of circularity, I would say we are on the halfway.
Of course, I have to ask about safety now. When you consider hydrogen being part of aviation of airplanes, then of course everything has to be 1,000% safe. Would you consider fuel cells and electrolyzers safe nowadays?
I would say they are. The most important issue is where to store hydrogen. So leaks are probably a problem because we are dealing with a gas. It's not like dealing with a conventional liquid fuel like gasoline or diesel. Also, we are dealing with high voltage electricity connections, right? So if you imagine a big electrolyzer with megawatts or gigawatts, you are dealing with high voltage electrical installations. But I would say this is a major technology, and it should not be a problem.
Let's talk about price here. We know that when it comes to batteries, the price has fallen beneath the $100 per kilowatt hour. How is that compared to electrolyzers and fuel cells? You just mentioned 1 megawatt electrolyzer, for example. Do you have any number for me? How costly, how expensive is an electrolyzer?
There is no I would say like a super big market for electrolyzers right now. So the suppliers are just keeping the prices like in confidential information, depending on the supplier, if they sell it to a university or if they sell it to a government. Or if they sell it to a private company, they sell different prices. But there are these European organizations, Hydrogen Bank, and European policies and regulations that I would say they put upper limits to hydrogen prices, and they try to regulate the price of green hydrogen. I think it's around 5 or 6 euros per kilo right now. But indeed, it's still more expensive than the hydrogen linked to carbon dioxide emissions, which is around €1 per kilo.
How long do they last? I mean, we can't kind of measure that in cycles.
In terms of fuel cell, it's counted in hours. So there is no a cycle of charging and recharging, because a fuel cell, it's working in continuous mode. As soon as you supply hydrogen and oxygen, you will keep generating electricity. Probably the most known one is this proton exchange membrane fuel cell that works at low temperature. And this is the one that we usually see for vehicles like Toyota Mirai or buses, things like this. These fuel cells last between, I would say, between 5,000 and 10,000 hours of operation. And they are very sensitive to impurities that hydrogen could have in the hydrogen stream. So this is important. If hydrogen is not produced by electrolyzers and is produced from fossil fuel sources, even small impurities of carbon monoxide they can drop down the typical lifespan of fuel cells. And for electrolyzers, I would say it should be something around same. So membranes are degrading. So, but this is just doing the proper maintenance and keep changing spare parts, changing electrodes, changing membranes, changing electrolytes. And in principle, the system is quite reliable. It's quite robust.
I know that you guys in UPC Barcelona, you do operate first research electrolyzers and fuel cells for years now. What is very surprising research results to you?
For me, probably it's for electrolyzers. We are mostly working with anion exchange membrane electrolyzers. Anion exchange membrane electrolyzers, they don't need critical materials in the electrodes like platinum or iridium. and they don't need fluorinated membranes, but they are very sensitive to the purity of water. And we dream to feed these electrolyzers with seawater, and now we need ultra purification systems to produce very highly deionized water. Otherwise, we are gonna destroy those electrolyzers. So this is driving us a little bit crazy. And also the pressure, the inlet pressure of that water, if the inlet pressure drops a little bit down, also the electrolyzers, they are having problems. And one of the other issues that we found on research is that they are not 100% compatible with the intermittence of the renewable energy sources. So you have to inject the electricity from solar panels to the grid, and then get that stable electricity from the grid to run the electrolyzers. You cannot directly plug solar panels to electrolyzers. You need the grid as a buffer.
It's very interesting to hear that you want to use seawater directly in Barcelona. I know you have lots of solar energy over there. That's a great dream. Let's dive into this technology. What do you do with the sodium and the chloride gas? I mean, that's going to be produced at some point. What do you do with that?
Yeah, honestly, we have a non-clear idea on what to do with those residues. We believe that we might sell, because there is a market also for sodium chloride. So in the case that we have to purify water before injecting that water into the electrolyzer, we will get tons of salts. And then what to do with those salts, this is going to be a challenge to overcome. But honestly, I don't have the answer for that.
All right, I'll ask again in a couple of years. Let's now talk about the ramp up of the European hydrogen market. Every day, basically we follow these huge hydrogen headlines. Sometimes we kind of lose track about the biggest news in Europe. Would you summarize really quickly the biggest news and events within the last years when it comes to the ramp up of our hydrogen technology here in Europe?
I'm actually a bit disappointed between the difference on the plans. So like the strategic plans and people showing very nice slides in PowerPoints, and then what is happening in the real world, what is happening in industries, so the real finance investment decisions, presence of takers. So I think there is a mismatch between what politicians expect to happen and what is really happening. But anyway, there are like some success or mid-success examples, like this hydrogen backbone with pipelines that should provide green hydrogen for different off-takers, hydrogen valleys. And I think this will happen in the midterm, because pipelines at the end, we have pipelines of natural gas. So it makes sense to build up pipelines and to make this big investment to provide renewable hydrogen to industries or to big cities that can consume this hydrogen. And at some point, public institutions have to start investing to start this hydrogen economy.
Let me summarize that for everyone who is not from Europe. In Germany, the Hydrogen Core Network has been approved last year in October 2024 with 9,000 kilometers of pipelines consisting of 60% of converted natural gas pipelines, sooner pipelines from natural gas. They're now going to be carrying hydrogen. This project costing about 19 billion euros, US, aiming for completion in 2032. What's your take on this? Do we need an entire European network of hydrogen pipelines?
I do believe that would be something that we will need in the midterm and actually in the long term. I believe we will need that hydrogen pipelines, and we will need those investments. But probably we have to split up in phases and see exactly in which places or industrial poles or centers we need to speed up this process of sending hydrogen in there, and in which places we need to speed up the facilities with big electrolyzers to produce that hydrogen, right? But we have to start from some point, because there are some applications that will be impossible to electrify, and hydrogen will be one of the solutions in order to stop emitting carbon dioxide.
Let me ask this very straight on this point. Where does it make sense to build hydrogen distribution networks? And where can we actually distribute hydrogen via trucks? Isn't that a solution we might think of?
The choice between a pipeline network versus trucking depends on scale demand, depends on distance between hydrogen production facilities and consumption, depends on economics as well, right? But if we identify high density demand clusters like hydrogen valleys in Germany or Netherlands or France or whatever, or even outside of Europe, and we identify places where we can produce hydrogen in a cheap way, renewable hydrogen in a cheap way, it makes sense to connect those demand centers with supply centers with pipelines, because pipeline at the end is the cheapest option to transport and distribute hydrogen. Truck is more expensive, but truck transport, probably it makes more sense if we have a lower demand or distributed customers, or long distance without pipeline access, like mountains where it's difficult to send pipelines, and also electrical networks, right? So these isolated places, probably trucks will be a better solution.
I bet it's really hard to talk about a ramp up of a market that is not there yet, but will be in place, let's say, in 10 years because of lack of alternatives. But yeah, last question for this podcast, Lluís. I hate to ask that. I know it's very hard to answer as well, but of course, let's talk about the price of green hydrogen. I know there is not even a price of green hydrogen, as there isn't a price for green electricity either. But of course, we have to differ between these colors of different hydrogen types. Is there something like a projection of a price of green hydrogen within this debate?
In Spain, there is a internal regulation from the government that sets the price of renewable hydrogen. I think it was 5.6 euros per kilogram. But we are producing our own green hydrogen or renewable hydrogen here at the UPC, and for us it's much more expensive. So, but also the price of gray hydrogen, those regulation institutions, they say that should be around €1 per kilo. And for us, buying a gray hydrogen cylinder, I think it's around €100 per kilo, because we just buy one cylinder, right? So it depends on the amount of kilos of hydrogen you buy. So at some point, if we can produce this renewable hydrogen cheaper than these €100 per kilo that we pay for one typical cylinder of hydrogen, those ones that are like almost 2 meters in height, typical gas cylinders, for us is we are winning. So as soon as we can start producing this hydrogen cheap enough, but this is a matter of time. So at the beginning, you do a big investment, you pay this capex, you pay for the electrolyzers, you pay for the solar panels, you pay for all the electrical conversion purification systems, you pay for the water deionization system. So you have to do a big investment. And at the beginning, the price it's very, very expensive. But as a matter of time, in years, the balance of the price is getting cheaper and cheaper.
We hope so. Thank you very, very much for your time and expertise. Dear audience, now it's time for you. Leave a comment in the comment section and tell us, what do you think about the new hydrogen market in Europe? Is that going to work? Where is the challenges and difficulties? And do you think it's going to work at the end? Take care. See you next time. Bye-bye.
Bye-bye.